Very good evening, all of you. Hope you all are doing well. Let's start with today's session. Quick recap of yesterday's session, right? In yesterday's session, we took the timeline of Java history, that is from 1990 till 1996, right? And then we started with features of Java, in which the first very important feature we discussed that Java is compiled and interpreted. Like generally, the languages are only compiled or only interpreted, but Java follows both. It takes the source code, compiles it into bytecode, and then that bytecode is given to the interpreter. Interpreter will statement by statement convert the bytecode to actual machine code and then give it to the underlying processor for execution, right? Then the second important feature we discussed, that is Java is portable and platform independent. So in that we saw if the source code is same, the compiled bytecode has to be same wherever you compile. You compile on Mac machine or Windows machine or Linux machine, doesn't matter. Everywhere the bytecode will be same if your source code is same. And portability means if you have compiled your Java code on one machine and you got a bytecode, you can give it for interpretation to any VM of the globe. Means that same bytecode I can give it to Mac VM, Windows VM, or Linux VM. Any VM can run the same bytecode, right? That was the second feature. And then the third feature we discussed, that is Java is object-oriented programming language. Why? Because in Java, everything is written or everything is encapsulated within a class, data, methods, even main also. Now, modern Java has removed those restrictions because modern Java, they're trying to make it more like scripting language. But ultimately, someone is going to wrap it in a class because it is a true OP. But still, it is not a pure OP. Why? Because some primitive data types like int, float, double, long, short, they are still primitive. They are not objects. Getting? If you want to treat them as an object, they have provided some wrapper classes. Using that, you can represent primitive as objects. Getting? And some people have developed hundreds of classes. They have arranged them in a package, and then they have said you can import those packages and start using those classes by creating objects. Okay? Now we will move with today some more features. Some two or three more features are there that we will take, and then we will dive into the programming part of Java. Okay. The next very important feature, that is Java is robust and secure. Okay. Now, why we should say Java is robust and secure? So there are many points in favor of this. Why we should say the language is robust language or a secure language. Okay. Robust means in any circumstances it will not fail. Okay. First feature which is in favor of this, in Java, strict compile time also and strict runtime also checking is done. Compilation time also, I hope you know now, yesterday we have seen that in Java there are two-step activities. First the program is compiled and then interpreted. So interpretation is called as runtime, and when you're converting the Java code to bytecode, that is the compile time. So during compilation also the checking is done, and during runtime also checking is done. Okay, see a strict compile time and runtime checking for data types. Okay, now what do you mean by compile time checking? I'll give some examples in favor of this. Suppose you have declared one variable of type integer. Okay, I hope all of you are carefully hearing. No? Whenever I tell you that when you join the session, focus here only. Don't get distracted. Don't just keep peeping in your phone and check the messages and all. For 2 hours, keep it aside. 1.5 hour, 2 hour. Okay. So int I. I have declared one variable I of data type integer. So as it is integer, it can only hold whole numbers. So you can assign value which is of exact size or lesser size. Means I can assign a byte to integer or a char to integer or a short to integer or integer to integer. No problem. Because in Java, auto widening is possible. Means small values can automatically get widened, but you cannot store a bigger value in smaller. Like I'm trying to assign a double to an integer. According to Java, this is double. Remember, not only in Java, C++. Unless and until you suffix F to it. When you attach F, it becomes float. Okay. Now it is double. So you're trying to store a double value in an integer. Chances are there that zero point 0.5 will get lost. Yes or no? As it is a double value, it's having a decimal part and int is a whole number. So this zero point 0.5 is going to get lost, which is Java not going to do on its own. Getting? In languages like C or C++, it automatically converts 2.5 to 2. That zero point 0.5 is lost and then it stores. But Java doesn't. Java will give an error for this statement. Getting? And it will say that possible lossy conversion from double to int. So this is type checking, and this type checking is happening at compile time. You understanding? Clear? This may happen for other situations also, where it is a wider value and you're trying to store in a narrow. When a bigger value you're trying to store in a, because 2.5 is double, it is a 8 byte, and you're trying to store it in an integer. And moreover, they are incompatible. It can contain decimal also, and this can hold only whole numbers. So in this situation, zero point 0.5 is getting lost. So Java says, as there is a loss, I won't do it on my own. Getting? If you want the loss to be done, okay, that zero point 0.5, okay, that zero point 0.5 is lost, no problem. Then you do casting. We will be learning about casting and all. Don't worry, there will be a separate topic on it. But if you are doing explicit casting, then you have already told to the compiler that if the loss is done, no problem. Convert 2.5 double to int and then store. Now it won't give error, but here it is sure a error. Okay, if you want, I'll show you quickly the result of this. Whenever in Java, if you want to just temporary see the output, temporary output means you want to see the output of some small code segments. Means you don't want to write the entire program for doing that. So Java people have already provided one interactive environment. It is called as interactive environment, which works on REPL concept. Now you'll say, what does that REPL means? That is read, evaluate, print, loop. So they have provided one tool called as JShell. Okay, JShell. This has been provided in the later versions. Means it was not in the very first version. If you have kept your uh, mic unmute, please see to it that it is unless and until you want to ask question. Otherwise, try to keep it mute. So JShell, it's provided in Java 8 and then later versions they have given. So this JShell is very much useful in the learning phase where you're just learning some small things and immediately you want to test and see. Like you have learned operators or just declarations or just input output. So no need to write an entire program for it. Only that much command you can type and run and see. Get it? So this J shell, when you start, it shows a prompt and it is waiting for you to type the command. Which command? Java command. It will read that command. It will evaluate that command, print the result of the command, and again it will show the prompt and it will wait for you to type the next command. So it is in an interactive environment. Therefore, we call it as read, evaluate, print. But just use J shell when you are in a learning phase, when you're learning small things. But when the whole learning is over and now whatever you have learned, you want to put everything in one single program, then you have to go for some integrated development environments like Eclipse or VS Code. Okay, so we will go to that thing also, but as now we are learning small things, so we can use this J shell. Now already JDK is installed in my machine, therefore it is okay. But today I'll show you when you install, assuming that you don't have JDK. So we will install JDK and then you will be also able to use this. We just have to type J shell. You'll get this prompt, J shell greater than. Okay. Now see here, I'm declaring with variable I, which is integer. And then I'm trying to assign 2.5 to it. I equal to 2.5. The moment I assign it, it will give a error. Getting the same error you'll get it if you write this whole thing in a complete program also. The same error because ultimately in the background it is being run by your VM only. Okay. See here. Is it giving incompatible type possible lossy conversion from double to integer? It is saying that this value, which is double, there some loss is going to happen because it's getting converted from double to integer. And such thing Java doesn't do automatic. Means in short, in Java, automatic narrowing is not possible. Automatic widening is possible. Okay. So I hope this point you will remember. So this point is in favor of compile time checking. Okay, see here, int I equal to 4.5. And this is going to happen for other data types also, where narrowing situation is there. Understanding? Or it's a Boolean variable and you're trying to assign an integer. See here, it is a Boolean variable. So Java says if it's Boolean, you're only allowed to assign only two reserve literal, true and false. But if I try to assign b equal to 10, again it will give an error. So these checkings are done at the time of compilation only. Okay. So you created an integer variable, you assigned a double to it, and it gives an error. Incompatible types, possible lossy conversion from double to int. Okay. Now we will see what is runtime error. Now runtime error means the execution time checking. Okay. So what that feature is, I'll tell you. Now suppose you already have a class, some class you have created. Assume an employee class is created. And now you're creating an object of it. See here. Assume there is the employee class. Okay. And then E is the object of employee. But remember in Java, when you just create a variable of that class, actual copy is not created. Means the instance is not created. Only a reference variable is created. Getting? E as the reference variable is created on stack part. Getting? And till you don't write E equal to new employee, it is not going to allocate memory on heap. How much memory? As much is needed for its data. Like employees internally having some data like employee number, employee name, salary, whatever. So that much memory is not yet allocated, only a reference variable. Now, this reference variable means you can think it like a pointer. But then some may go against with me that you'll say you are saying all contradictory thing. In the history, you said Java doesn't provide pointer, and now you're saying objects are reference. Getting? Please remember, though we say E is holding the reference, actually it will not hold the direct memory address. It will store a reference or it will be referring to one hash table which your virtual machine maintain. And inside that hash table, the actual memory address is there. Therefore, we never get the direct memory address. But that internal things I'm hiding. Okay. And I'm saying E is going to contain the reference. So employee E when I write, actual instance is not created. Instance means object or copy of this class is not created. Getting? So unless and until you write E equal to new employee, okay, and the constructor is called, it is not going to allocate the space on heap. In Java, all the objects are created on heap only. Okay. So how much memory? Now, new is an operator which is asking to the VM. It is requesting to the VM that please allocate as much memory is needed for employee. Okay. So VM will reserve space on heap as much is needed for its data, like employee ID, employee name, salary, whatever. Memory allocated, then the reference is returned. Actually, that reference is put into a hash table and then the hash entry is given to us. Getting? So ideally in Java, never we get direct memory access, but I'm saying that leave it. That part we will assume it is hidden. So we are saying the reference we get for that, and then we store it in E. And then we can access the methods of that employee by doing dot and then calling the method E dot get employee. Sorry, get salary. Suppose a method is there called get salary. Okay. So what I wrote, employee E object is declared. This is the object declaration. So only a reference is created on stack. Then instantiation is done. New employee, a copy is created on heap. The reference is stored here. And now using that reference, we are accessing the methods of that object. E dot get sal, suppose. Now it is okay. But suppose by some means you forgot to do this work. Okay, you wrote EMPE and directly you're doing E dot get sal. Understanding? So what happens is this code is syntactically correct, though you have not written this part, only first line and the third line. Compiler doesn't complain. Compiler doesn't complain. Compiler says syntactically everything is fine. You have declared an object, then you're accessing the method. But runtime, when VM tries to execute it, getting when virtual machine is trying to execute the bytecode of it, and when it reaches here, e dot get sal, it will throw a runtime error called as null pointer exception. This is a class in Java, and it will raise that problem at exception. Okay, so runtime exception. This exception is thrown. You can trap this when we will learn try catch blocks and all exception handling. We will see how to trap and all. So E dot get sal raises this error. And why it raises this error? Because in E, that time, reference only won't be there. Will this thing be there at that time? In E, there won't be a reference only. And as there is no reference, how can you access the method of it? Inside E, what is not there only? As there is no reference only, how can you access the methods? Getting or no? Means the baby is not yet born only. How you can file income tax for that baby? Or you're purchasing property by that baby's name? Or you're purchasing shares and dividend shares and mutual funds and gold and everything, where yet the baby's not arrived only in this world. Getting? So it is illegal to access the methods of an object which is not existing only. Memory is only not allocated. How can we access the methods of it? You understanding? Because in E, there won't be null reference. Reference only is not there. Same thing in C++ or C, you try to do it. No? There, what happens is it just crashes your program. Getting? That core dump and it will crash your program. Here it throws a exception. Very elegant way. You can trap these exceptions using try catch and gracefully you can continue with your program. Okay. So employee E and directly you wrote E dot get sal. It raises this. So this is also checking only, but this checking is happening at runtime. Okay, I'll show you this thing also. This error also I'll show you, don't worry. See here. I've already created one class employee and then I created one variable of it, means object. Object is just declared, guys. It is not yet instantiated. According to Java, this is just object declaration. Unless and until we write new employee, instantiation will not take place. Copy of that is to be created. So employee E, and directly you're calling the method of that class. In this case, at runtime, syntactic, no problem. Grammatically, this program is okay. So compiler doesn't complain, but the VM will complain, your interpreter. Why? Because it sees that in E, there is no reference only. It throws null pointer exception. Why? Because E doesn't contain reference only. So how can you access the methods of it? You're understanding, no? The copy is only not created. How can you access the methods and data of it? Okay, so accessing method without object instantiation. Instantiation means allocating space, creating copy. When we create a copy of that class, we say the object is created. Okay, so accessing method without object instantiation. We forgot to do this thing. E equal to new employee. If I do this line just before it, it won't give error. Okay, I'll show you this demonstration also. Okay, see, I'm just creating one class employee, and for time being, I'm just adding one method. Okay, public double get sal, which is just returning some hard-coded value of 4500.0. Okay, enter. Right? The class is created. Class employee and just one public method which is returning double. Now I'm creating a variable of it. C, emp-e. Okay. And then I'm trying to access e dot get sal. E dot get sal. Can you see when I created emp-e, what is the value in e? Null. And as the value in E is null, how can you access the method of it? The object is only not created. Getting on? No? See here. Does it throw null pointer exception? And as we are doing in this environment, this shell environment, see the shell runs in this pattern. Okay, it is running in this pattern, that is REPL, read, evaluate, print, loop. Later, what we'll do after learning the basics like data types, then literals, operators, keywords, identifier, all these things, knowledge, once we gain it, then what we'll do, we'll start writing complete programs. So that time we will switch to Eclipse or something, because that time you will be eligible to write a complete program. Okay, so that time I'll show you how to write a complete .java file and then write a class in it and main and all those things. Now we are just learning small things. So only that much part we are testing in this interactive environment. Get it? But there also we'll get the same error because ultimately VM is same in the background. Execution is done by the same VM. Okay, so I hope you got it. But suppose now I am writing E equal to new EMP. Okay, now E has got the reference. See here, in E, the reference has come. Actually, many think that this is the address in a hexadecimal form. This is actually a hash code in a hash table. And in a hash table where that entry is done, that bucket address you get. And there the actual memory address is given. Therefore, in Java, there is no means by which you can get the direct memory address. And that is the reason in Java, we cannot get direct access to memory and viruses sort of things cannot be developed here. Okay, now the object is instantiated on the heap. You got the reference. Now if I call e.getSal, it doesn't complain and it will return that hard-coded value 4500. Can you see? Okay, so can you give me the confirmation if This both things are clear. That is compile time and runtime.
Yes, sir. It's clear.
Sure, na? Others also. Okay. Moving to next point. So point one is clear. Because of this, language is to be called as robust language, secure language. Okay. Second point, automatic garbage collection is done. Now that is also related to objects only, object creation. Okay. See here, automatic garbage collection. There is no need to release memory explicitly. Okay. Which we have to do it in C++ by calling delete. You remember, no? Like if I write star p equal to new, and again after some time I write p equal to new. So what happens is in p the new address come, the old address is overwritten, but the old address where it was pointing that you have not freed, means you have not informed to the OS that take this, I don't need it, by calling delete. So that memory leak was there. Why memory leak? Because it is neither freed nor accessible. You lost the address, therefore you cannot access, and you have not told to the OS, so it is not freed also. Getting same thing happens in LIC. Now you may say, sir, part-time LIC agent, not like that. In LIC also, now so many people take life insurance, and there is crores of, crores been hundreds of crores amount in LIC which is dead. Dead means you can say no one is coming to claim it. Means X person took a policy and he didn't inform only to his relatives or anyone that I have taken this. And suddenly, by some means, he died. So those relatives are not going to LIC also to claim it. And he also didn't inform to everyone. So such amount, there is crores of amount with LIC, which is amount who is no one claiming on it. And therefore they utilize it in some other way. Okay, but I just wanted to an example relate that how such money is there with those LIC people. Okay, so memory leak concept won't occur. See here, you created one object first, employee E. First you have created E equal to new employee. Okay, so first object got created on hip. You got the reference. But after some time, again you're creating a new object of the same class. Okay, and the reference you are collecting in E only. So E is containing the old object reference. Now that old reference will be overwritten by this new reference. So from us, that old reference is lost. No problem. That memory will be automatically put into free list by the garbage collector. But there is a garbage collector, which is a low priority thread, which your virtual machine runs periodically. Periodically means it will not immediately call when the reference is lost. It is scheduled. It is scheduled. Means after this much millisecond, after every this much millisecond, you have to call this garbage collector. So whenever garbage collector is called, it will check how many objects are there whose references are lost. It will put it into free list. Again, when it is next scheduled, again it will check between this duration how many objects are there who have lost their references. It will collect all of them and put into a free list. Getting? So remember, garbage collector doesn't come immediately. Like when you go to a multiplex, when you go to a theater for watching movie, okay, so you can see like there is a housekeeping team. Before the movie start, that whole team go inside with a vacuum cleaner and all those their props, whatever are there, and then they completely clean the theater. Then people go. Then, though we call ourselves as educated, we call ourselves as civilized, but still, lot of things, dirty things we do. We drop popcorns, then so many things. The ice cream wrappers you insert somewhere, getting so immediately the housekeeping team is not coming. If the popcorn uh, that basket is dropped, immediately they don't come. They will wait till the movie doesn't get over. So it is periodic. Means when that movie is over, people will go. Now they will come, clean. Again, their schedule is when next movie will get over. So same way, it is scheduled. After every fixed interval, this garbage collector is called. And between the duration, if there are objects who have lost their references, they all are collected and put into a free list. That is the reason we say in Java there is no delete operator. You don't have to explicitly free the memory. Automatic garbage collection will be done. Getting? Now see here, what I'm saying, E is on stack. First object got created, memory allocated for ID, name, salary, whatever. It is referring that. Now, whenever any object is referring, sorry, whenever your reference variable is referring to object, a ref count is maintained. A ref count is there. Means there can be one more object which is having same reference. So that is also referring here. So ref count will be 2. We'll be learning about that too again in one topic when we'll come to operators. Okay. So a ref count is maintained. Always remember. Now what we did, we created one more object and the reference of that object is kept in this E only. So the old reference is lost, it is overwritten. So when this reference is overwritten, internally what happens is where it was previously referring, its ref count is reduced. Getting? This reference is lost, but internally the system is made like that. That when the new reference is copied, where the previously it was referring, its ref count is reduced by 1. Getting? Now the reference lost, new reference come. Now you can check this object's ref count has become 0. Means this object is eligible for garbage collection. But will it be put immediately to the free list? No. Whenever the garbage collector is scheduled, whenever it is scheduled, it will come and check in the memory how many objects are there who are having ref count 0. So all those objects whose ref count is 0, okay, they all will be put into free list. Everything is inspired from the real life. Remember, basically programming is only inspired from the real life. Getting my professor, Dr. Desai, 30 years back, I'm talking, he used to always bombard on us. And that time he was 81 years. Now he's no more. But that time 81 is two people used to come along with him as an escort because so aged person. But the enthusiasm of teaching was extraordinary. I think he used to always say, programming is inspired from real life. Whatever you see in the surrounding, everything is being picked from the surrounding and it has been implemented in the program. Like humans have life, program is also having life. Humans are born, they enjoy life, they die. Same way program is created, the program execute and the program terminate. Getting? So I hope the garbage collection concept is clear. So no need to explicitly release. A low priority thread is there called as a garbage collector and it is called periodically. And the job of garbage collector is to check the objects whose ref count has become 0. It will collect all those objects and it will add it in the free list so that that memory can be reutilized. Getting? I'll show you with a example this automatic garbage collection. I've written EMP E equal to new employee, and after some time, dot 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 means in between you have written some code, and then E equal to new employee. This is the stack part and the heap part. Always remember stack part means that memory where the variables who are having name are kept. Those which have name are kept on stack, and those who don't have name are on the heap. So those who don't have name means what they will have reference, and that reference is kept here in the variable who are having name. Variables who are having name, in that the reference is kept. Okay. So always remember heap is a unnamed memory, but it is managed. Getting? Stack is a named memory, but it is not managed. It is not in our control. Automatic at entry, they are created, and exit, they are destroyed. So we will talk about heap, stack, everything when we'll come to variable and their scope. All topics are there in the pipeline. Don't worry. Okay. So on the stack, one E object is created, a reference variable. Then we wrote E equal to new employee. So one object of employee class created and its reference is stored in it. After some time, you created a new object. So that new object reference is overwritten. So obviously the previous reference is lost. Getting? The new reference is overwritten to lost. So internally the system is like that, that when you lost any reference, that reference count is decreased. Getting? So now this object will have zero ref count. So that object is eligible for garbage collection. But remember, immediately it is not. Getting? You go to malls and also there also they are doing periodic work. Their schedule is there that after so much time only we have to come for cleaning. Getting? It's not like your mom at home. Getting? Who 24 by 7, she's always busy with doing work only. Right or no? You do anything, you are doing anything untidy thing, and she's there to clean it. So that way the work is not there. Here it is very systematic. It is done in a scheduled way only. Getting? So point number 3 is clear to you. Okay, so just give me quick confirmation that the second point is also clear.
Got it, sir.
Sure, na? Okay. So I hope it is clear that how the automatic garbage collection takes place. You don't have to explicitly release it by writing new delete E. Delete operator only is not there with Java. Okay. There is a low priority thread which is running in the background. Who runs it? VM is running, and VM is invoking it after every fix interval. Getting? Then the third thing is Java has provided this exception handling mechanism. And because of that, you can write very secure code. Means you think that this code may probably create any problem at runtime. Okay, you have written some code, but there are chances that this code may create some problem. Okay, when you are 100% sure that this code will never create a problem, then there is no need only of doing exception handling. Okay, so there are probability, chances that this code may create problem. And if you have not taken care of that, then sure your program is going to terminate. Getting? Virtual machine kills your program. It is killing. Your killing concept is also there. Like in real life also, humans die by three ways. They naturally die. They've lived their life and they'll naturally die. Second, someone is killing that human. And third, that human is killing itself by suicide. Same, exact same mechanism is there. Your program can kill itself. VM is killing your program because you have done something wrong. And the program is naturally terminated because it has completed its execution. Getting? So in this code, there is a chance of problem which can occur at runtime. And if you have not taken care, your program will terminate. But you want to gracefully terminate. Getting? So you can put this whole code in a try block. Okay. In C++ also, you might have learned, if you have learned C++, no problem. So try block is running. If in a try block there is a problem, gracefully the control is transferred to a catch block. Getting? And in the catch block, you can take care of it by giving appropriate error message, and still you can continue with the remaining code instead of killing the program. If you don't put this in a try block and the problem occur, VM is sure going to kill. Abnormally, it will kill it. The program will terminate over there only. But if you put it in a try block, graceful handling is there. The control is transferred to the cache. In the cache, the problem is handled, and then it will continue with the remaining code. So with this, you can eliminate the runtime crashes and all, okay, by handling all those problems. So exception handling captures serious errors and eliminates any risk of crashing system. Because if you don't write it, sure your VM will terminate your program. Terminating is VM has terminated means it has sure killed it. Your yourself terminating is also possible. And no need to do both when the entire program is executed successfully. Correct? So by three way the program terminates. Okay. So this point is also clear. See here. You can write such very systematic try catch block. So in a try, you add the code which may probably create a problem. If problem occurs at runtime, the control is transferred to cache, you handle it, and then continue with the remaining code instead of crashing the system. And last point is pointers. Java has not given pointers, so no direct access to memory. So obviously it is secure only. If it gives direct access to memory, you can create a havoc in the system. You can modify the interrupt vector table only of your OS. You can damage that IVT. There you can hook any rotten code. Getting so that things cannot happen. Okay. So all these points are in favor of Java, robust and secure. Okay. Okay. So just give me confirmation so that I'll move to the next point quickly. Yes or no? Sure.
Yes, sir,
All of
got
you.
Yes, sir.
Clear? The interaction, as I said, like interaction has to be there, guys. Okay. Though we are in a virtual mode, think as if we are in a classroom only, right? Or no, in college and all, when you attending lectures, so you interact with your teachers and professors. Exact same. Only the mode is different. Okay. Then one last feature we will take to move in the programming part. That is, Java is simple, small, and familiar. There are some more features, but at this point, not needed. Now, to start with the programming, these many features are sufficient. There are some features like Java is multi-threaded, Java is dynamic. Okay. So when we'll come to those chapters, automatically you'll come to know. Okay. First, we'll just talk about Java is simple, small, and familiar. First, remember Java is neither superset nor subset of C++. Okay, like when we say this is C language, so C is completely incorporated in C++. Always remember, everything what is there in C is there in a C++ with the incremented features like classes and private, public, all those things, constructors, destructor, and all. But the data types and for loops, switch case, if else, parameter passing technique, all is from C only in C++. So for C++ and C, this is the relation. Therefore, in many books, if you see, they say C++ is a superset of C. And that is the reason they have used that plus plus operator. Actually, plus plus is an increment operator. No? Plus plus is a increment operator. So why they have put plus plus after C? Because it is a incremented version of C. Whatever is there in C is there in C++ with many more additional features added. Okay. But Java, you can say, is something like that. Means it has taken all the good features of C and C++, but it has added its own also. Lot many features are there in Java, extra features. But the problematic features like uh, pointers, header files, go to, okay, then friend functions and friend classes and all those things are not here in Java. Okay. So Java is neither superset nor subset. Okay. Now why we should say simple? Because all the complicated features were there, the features which were difficult to use that are removed in Java. Okay, like that header file concept. Whenever you need any library, you have to include that headers. Getting then that go-to feature because of go-to code mangling is there. You can create problem in your code because of that go-to. Okay, so that go-to headers, then problematic features like pointer. Many people still don't understand pointer. Getting on means there are people who are in working in industry, but still they are afraid of that pointer concept. It is so exhaustive thing, no? Like simple pointer, then double pointer, and pointer to array, pointer to structure, array of pointer, pointer to function. So many things are there in it. Getting so they're all confusing. So we say it is simple because all these things are eliminated. Small y because many features are reduced. Okay, reduce like they have reduced operator overloading. In C++, we have operator overloading that is removed. Friend functions and friend classes and all because they are going against the OP features. So those features are eliminated. Okay, so operator overloading is not there. So some features are cut off. Therefore, we can say Java has become small comparative to that. And why we should say familiar? Because lot of things from C++ are still there in Java, like access specifiers, public, private, protected, then control flow, if else, switch case, for loop, while loop, do while loop, break, continue, many data types, lot of operators. So all those things which were there in Java are still, sorry, were there in C++ are still there in Java. So people are already familiar with those things. Therefore, we say it is familiar. Okay. So why? Because difficult things to use, not there, therefore simple. Lot of features are cut off, so language has become small. And the features which you were already knowing, they have carried it, therefore those features are familiar to you. Okay, see, this is the relation of Java with C++ and C with C++. Okay, you can say Java is simplified version of C++. Means all the good things we have still carried, but whatever problematic things were there, that we have not carried over. Okay. See, features like few, there can be many more, but few I have enlisted. Feature like pointer. Obviously, many people, unless and until they don't master on it, if you know about YP Connect, he has written a separate book only on pointers, understanding pointers in C. And exhaustively, he has explained how much things you can do using that pointer. Okay, I remember so many years back he had arranged a seminar in that COEP for 3 days, and then when I attended it, then I realized that I am a ant only, ant, mungi. So much knowledge he's having only on pointer. Getting? But it was long years, so many years back. So pointers, many people feel difficult to use. Then this header files and all, or go to you can using go to you can transfer the control to anywhere, like you are inside a for loop and using go to you can jump out and then again you can take the control somewhere, so it is called as spaghetti code. Okay, spaghetti you only eat, no? You're using this, you can write a spaghetti code. You can do code mangling, that is you can move the flow from anywhere to anywhere. So it is a highly discouraged feature. This is not a recommended feature. So all these are difficult features and they are removed in Java. Therefore, we say Java has become simple. Then some features are eliminated, like operator overloading. Okay, C++ provides, Java doesn't have. Multiple inheritance, diamond problem won't come. So such like I have not enlisted more like friend class, friend function, inline functions, all those things are removed. Therefore, they are not there in Java. Therefore, you say Java is has become small comparative to that. Okay, and features like data types, control flow, okay, if, switch case, for loop, while loop, all those things. Lot of operators like arithmetic operator, increment, decrement operator, assignment, comparison, logical operator, bitwise operator, they are nearly same. Getting means 99% same. Some few one or two more they might have added in Java. So all these features are already there in C++, carried in Java. Therefore, people who are going to work in Java, they're already familiar. Okay. So that is the reason we call it as simple, small, and familiar. Okay. So for this point also, quick confirmation so that we can now enter into the
Yes, sir.
programming part. Now, next is we have to start writing Java code. Okay. But to write Java code, there are two things. If you just want to run your Java code, someone has already created the program and they've created bytecode, and that bytecode they have given to you, and you just want to run it. That is possible because to run that Java code, Java runtime environment is already there in every machine in the globe, which yesterday I told you. Whenever you install a OS on your machine, getting whenever you install a OS, automatically that runtime environment is there. Therefore, any bytecode in the globe can be executed in your machine because to run it, VM is there. Okay, 1 minute, guys. Okay. Sorry for interruption, guys. Let's continue. So, if you want to just run your code or run your bytecode, someone has given you the bytecode and just you want to execute it on your machine, no problem. You have the runtime environment already installed. But if you want to develop your program, like you want to write your source code, then you want to convert that source code into a bytecode and then run it. Then you need to have Java development kit. Okay. And in some OS that JDKs also come automatic. A best example is open source OS. If you are using any open source OS, na, like Linux version, I don't know whether you have used it or not. Actually, we recommend it. Use open source OS free, like Kali Linux or Red Hat or Fedora or Mandriva, SUSE, so many are there. So in that, no, JDK also they ship it free, but on Windows and all they don't give. Then you have to download and install it. Okay. So if you want to develop your code and then execute it also. Develop meaning you want to write the Java code. Now you say Java code I'll write in a notepad also. Okay, you wrote the source code, but now you want to translate it into bytecode. So you need to do translation. Sometimes there are many bytecodes and you want to combine them into a jar file so that I can send it on the internet. So you need a zip tool. Zip tool means compressor tool. Or I want to debug my code. Okay. Or I want to retranslate a bytecode again back to source code. So I need a profiler. Okay. So some tools are needed for developing. And after that, once you have created a bytecode, you need to run it also. And when you run it, you need the libraries also, no, which Java has provided. You are already using them. You have not created them. Many are there, like string class, system class, print string class, so many. They are ready provided. So I need those classes also, which I haven't developed. Some people have given me. Getting? So all these things, if you need, then you need a JDK to be put in your machine. Okay. So remember, a Java development kit is needed when you want to develop also and execute also. If you already have a bytecode and you only need to run, then you need a Java runtime environment. Okay. Now I'll give you the relations. Don't worry. Okay. What this Java development kit is made up of. Okay. Generally, these Java development kits were initially categorized into three, like standard edition, enterprise edition, then micro edition. That is one edition specially for cell phones and all. For web development and all, they introduce enterprise, then only standalone, then standard. So nowadays, it's not like that. It's a common JDK for everything you can use. Okay. Only their versions are coming continuously. Some versions are preview versions, some are long-term support version. They are called as LTS. So for few years, Java 8 was acting as a long-term support, Java 8. Now 17 is there. Okay. Now other versions also have come, but 17 is still assumed to be as the long-term support. Okay. So JDK is having Java runtime environment. Actually, this is already there in your machine. But if you install JDK, then also this will come. Okay, so this will be the different one and which is already there. It is kept in some other folder. So now it will start using this JRE. Okay, so Java runtime environment and the tools. There are many tools like Java compiler, Java C, debugger, profiler. Okay, so many are there. And this Java runtime environment, which is providing you like a platform, means it behaves like a OS. And what is the job of OS? Provide you with the services. No? OS does the service provision work. No? It allocates memory for you, then loads your code from disk to memory, then it gives facility for input output, garbage collections, scheduling, processor scheduling, and all. So similar work this environment, Java runtime environment does. So see here, JRE is further made up of Java virtual machine and the libraries which you need for your execution in your program. Because in your program, you have not developed this. You are already using which Sun has provided. You wrote your program, but in your program, lot of things you are using ready-made, which Sun has given. So they are in this libraries. They are called as Java APIs or Java software libraries. Okay. Either you call it as Java API, Application Programming Interface, or they are called as Java Software Libraries. So these libraries and your virtual machine not only does one main work, that is translating the bytecode to machine code, statement by statement, converting bytecode to machine code, giving it to underlying processor for execution. That is one responsibility, but it is having many other responsibility like garbage collection, memory allocation, thread scheduling. Okay, if you are doing thread-based coding, so the CPU is to be scheduled between them. Otherwise, there will be a fighting in them. So in a round-robin manner, the thread is scheduled. Means everyone will get a fixed time attention of the CPU. So the scheduling of the thread, all job this VM does. So VM's main work is translating bytecode to machine code. The main task. Second, allocation of memory for your objects and on the stack and all. Third, garbage collection. Fourth, scheduling of thread. All that is the job of VM. Therefore, in many interviews, they say that is VM platform? Yes, then comment on it. Platform is it acting like a OS? Yes. But this VM is running above your OS, huh? And your OS is interacting with the hardware. Always it's a layer architecture. Huh? Above hardware there is OS, above OS there is VM, and VM is running your program. And your program is controlled by you. That way, the layer concept is there. Okay, and the libraries, because without library, your program won't run. Because in your program, you're using those ready-made things. So those ready-made things which are developed by some people, they are here, right or no? And different tools are there. So always remember, JDK is made up of JRE and tools, and JRE is made up of VM and libraries. Okay, okay. So whenever anyone asks what is VM, then you have to say it is your Java interpreter, and it is like a platform. Its main responsibility is to convert the bytecode statement by statement to machine code and give it to the underlying processor for execution. Garbage collection, memory allocation, thread scheduling, all that job. Okay. And JRE provides you with this virtual machine and the libraries. Therefore, we call it as runtime environment. It is providing you the platform for running your bytecode. It is providing you the environment where you can successfully run your bytecode. So only VM is not sufficient. The libraries are also needed because you have used them in your program. Okay. And the tools needed for translating your Java code to bytecode, or there are many bytecodes and you want to combine them into a jar file so that it becomes easy to distribute on the internet. Then we have debuggers, profilers. Previously there was applet viewer also. Getting now it is been discarded. So all these tools, this whole thing makes JDK. Correct? So suppose JDK is not installed, still there will be one default JRE in your machine. Generally, it is in Windows folder. If you go in Windows folder, uh, like if you are using in Unix, it will be in USR share, USR/share, their folder it will be. Here it is in Windows folder only. If you go, there is one Java folder. And in that Java folder, you will see the default VM which comes along with your OS. But if you install JDK, then it will also provide one JRE to you. So when we set the path of our JDK, then onwards it starts using this JRE, which has come in the JDK. Okay. So how to download it and all quickly we'll see. We will install also. Don't worry. And then we will start doing some coding. Okay. Now I told you initially we will go with small parts, and when all that small things are complete, then we will combine them with a single program. Okay. So Java development kit. So I hope this picture resembles that. If you want to develop like a painter needs his brushes and the tray and the colors and all those things. So it's toolbox, right? A tailor obviously needs whatever things are there, right or no? So everyone wants their tools. Like mom is preparing anything in the kitchen, so she needs her tools. Same way for your programming, you'll need JRE and the tools. They all come under JDK. Okay. So Java Development Kit provides environment to develop and execute your Java program. Means it gives facility to convert your Java code to bytecode, as well as that bytecode you can run also. Okay. Then it is providing you the tools to develop your Java program like compilers, debuggers, and all. Actually, this interpreter comes in that VM only. Okay, so debuggers are there, profilers are there, many other tools are provided. Nowadays, that J shell and all that also come in this JDK, that J shell which I showed now. Okay, and then it provides a runtime environment, and using that we can run the bytecode. So to run that bytecode, we need that JRE. Okay, then what does that JRE provide? The Java runtime environment. So I said like it gives you the facility to run your bytecode. Okay. So it is providing you the environment where that bytecode can be executed. Okay. So how it gives that facility? By providing one virtual machine. And that virtual machine's job is take the bytecode, convert to machine code, give it to the processor. Then allocation work. garbage collection work. If your program is having multiple threads and then they are running simultaneously, then their scheduling is also to be done. So all that task it does. And along with that, your program needs libraries because those you haven't developed it. It's already ready provided by some people and that you're just using in your code. So that all things come under JRE. Okay, see here. So JRE provides environment to run, not develop. If you want to develop, then you need tools which come in JDK. But this is also part of JDK. I told you, no, JDK is made up of JRE and tool. JRE is made up of VM and libraries. Okay, provides environment to execute Java program. What does this JRE contain? One very important thing, that is Java virtual machine. Same concept is there in Python also. Python is having its own virtual machine called Python virtual machine or a PVM. Same thing is there in your .NET framework. If you're interested in the .NET framework also, in .NET framework also they have their own VM. Only the speciality of .NET framework is it allows you to use more than 40 languages. Here only Java. That all 40 languages get converted into a common assemblies. Here we call bytecode. There they call it as assemblies. And then that assemblies are translated into actual machine code by their virtual machine. Getting? Here Java is having its own virtual machine. So JRE consists of virtual machine and the libraries. Because without libraries, your work will be very difficult. Otherwise, then you have to develop everything. You need a linked list, you need a set, you need a hash table. Okay, so for all that, you don't develop, it's already provided. So Java software library, also called as application programming, and how they are provided in the form of packages. Hundreds of classes are there. They have organized in the form of package. There is a main package called Java, then we will have sub package, then in all sub package there are related classes. Your job is just to use it in your program by importing, and then how you will use it by creating objects. Okay. And always remember, if in your machine you haven't installed JDK, then also in your machine there will be a default JRE. Every OS is shipped with a JRE. Getting? Though your machine doesn't have JDK. So if you haven't installed JDK, there will be one default JRE present, which is there when you installed OS. But now if you install JDK, then JDK will also give a JRE. So henceforth, now it will start using this JRE, which is coming in JDK. Okay, now it will not use that JRE which was there already in your machine. Okay, so every OS is shipped with a JRE, though it doesn't have JDK. Okay, and only needed when you want to run your Java program. When you want to execute any bytecode, then we need JRE. Okay, and then inside JRE, what is there? Java virtual machine. But we call it as a machine. Many times now, when we say machine, so in your mind map, the picture of a physical device comes. So it is not a physical device, it is a program. Therefore, the name is given virtual machine. It is not a real physical machine. Okay. So what is this program going to do? The first task I told you, conversion of bytecode to machine code, and then other responsibilities. And generally, those responsibilities are of a OS. Therefore, many times it is called as a platform. If you read Herbert Sheet, complete reference Herbert Sheet, in that line is mentioned also that virtual machine is a platform, and then why the justification is given. So acts as a platform. VM acts like a platform, like your OS. And what is OS doing? Service provider. OS is a service provider. It gives services to our user program. Like it gives service like adding, loading, allocating memory, loading your program from this to that memory, right or no? Then creating objects at runtime, freeing them, then giving the CPU attention to you, scheduling of your CPU, scheduling of IO devices. All that is job of OS. Okay, so same task VM does. Interprets statement by statement bytecode into machine code and then gives it to the underlying platform for execution. Okay, responsible for memory allocation through new. Okay, and garbage collection means when the ref count of an object becomes zero, it will put it into free list. There is a low priority garbage collector, low priority thread called garbage collector. It is scheduled for fixed interval. It will come after every fixed interval and do that work. Then in your program, if you have written multitasking code, means you have written four parts and they are running simultaneously. They're all running SEM. So all are requesting for the CPU attention. So CPU cannot give attention to all four at a time. So there will be a round robin manner. I'll give some attention to this. 5 millisecond done. I'll leave that. I'll go to another. So this way, all are executing in a time shared manner. So who will get the next CPU attention? That scheduling is to be done. That is the responsibility of VM. Okay, so you can relate this picture. You can see this picture also Gemini generated and gave me. I just gave the prompt. I gave a prompt like JDK is made up of JRE and tools. JRE is made up of VM and library. First this much and such. And before that I gave that please generate an image for this and that statement I wrote. Such beautiful picture it has generated and given to me. You think it is a very easy mind map for you. Pictures you remember very easily. You know, your human brain is made like that. That it can remember images more than the text content. Right? See here. Java development kit. It is a superset of JRE plus development tool. A lot of development tools are there, like your compiler, the debugger, the archive, that is compressing many classes into a single jar. Why? Because sometimes you have to transfer it on the internet. So that time it is good practice to send all combined instead of sending one by one classes. We'll be learning all this. When we'll come to Spring Framework, database connect, you'll see lot of jars we have to download and then put it in our application. And many other tools are also there. Getting? So these tools and the JRE, Java runtime environment. It is providing or it is giving the facility to execute your code. So JRE contains virtual machine, which is executing your bytecode. Java executables are bytecodes. So it takes bytecode, converts to machine code, give it to the underlying processor. But in your code, you might have used many ready classes, no, which Sun has provided. So they are called libraries, pre-compiled classes. They all are in different packages, and you have imported that packages in your code. So those so relation, I hope you got it. Clear? So quick confirmation regarding this.
Yes, sir. Clear.
Yes,
Sure,
sir.
no? Just some information, though I have not put on the slide, but from interview perspective and all, you should know that after Java 5, from 5 onwards only you can say, okay, they introduce one more concept in this VM, inside VM, called as just-in-time, JIT. It is called as just-in-time compilation. But then you may say, why it is using word compilation, whereas this is in VM, whereas VM takes the bytecode and converts to machine code. So why the word, this is in the interpretation step, no? So why the word compilation is used? I'll tell you. But just for improving the performance of execution, how the Java bytecode can be executed more faster. Correct? So they focused on that, and then they later, in the later version, they added this. It was not there in the very first version. Okay, called as just-in-time compilation. So what this JIT does, JIT is a part of VM only. What it does is it sees in your bytecode the frequently needed bytecode. Okay, as an example, I'll tell you. Like you have written one function foo, okay, and in that logic is there, and you have called that foo many times. Okay, many times that foo is called. Okay, so what was happening when JIT was not there? As many times you're calling foo, that many times that foo's bytecode was getting converted into machine code and execute. Again, foo is called. So again, the same bytecode of foo getting converted to machine code, execute. Compilation is already done. The code is already compiled to bytecode. Now that bytecode is running, but such situation where you're frequently using the same code. What was happening? That many times the frequently needed bytecode was getting converted into machine code that many times. So to optimize it, just to make the performance little better, they introduce one concept called JIT. So JIT is doing some intelligence work. It is a smart behavior. So JIT will find out the frequently needed bytecode, and once only that whole bytecode, it will once only convert to machine code. And as it is, the whole bytecode is getting converted to machine code. The word compilation is used because it is following the compilation policy. Getting? So the frequently needed bytecode is getting at a time only converted to machine code. But still, this machine code is in memory only. Yeah? It is not in a file form. It is in memory. But later, what is happening when you're calling that function? It is not every time translating. Every time it is using this machine code only, which is already converted and kept in the memory. So second time also it will use the same machine code. But this machine code is in the memory till your program doesn't terminate. The moment it terminates, it is lost. Huh? Next time when you want to run the same bytecode, again JIT will come into action. It will find the frequently needed code, once only convert to machine code, and then use that machine code only again and again. I hope you're understanding. Is it increasing little bit performance? Better than the previous. Instead of every time translating the bytecode to machine code, why not to translate that frequently needed bytecode once only in the machine code, keep it in the memory, and then use that machine code only every time instead of again and again translating. Okay, so that was introduced in the version, I guess Java 1.4 or 5. In that they introduced it, but it was not in the very first version. Okay, remember. So these points you should remember. Okay, so if you are not having JDK, try to install it. It will be better. I'll open a new window only. Just you have tried download JDK. No rocket science or anything. Getting very simple. And if you already have, well and good, no problem. So download JDK. You have gone to google.com. Your search engine has come. Okay. It's up to you which search engine you're using. If you are a Mac user, you'll use specific search engine. You have typed download JDK, enter, you got this result. Just go to the first result and you can download the latest one. See here, the latest one is available. Okay, 26, 25, 21. Now they're saying 21 is going to be the more stable version. See here, 21 is the long-term support and even 25 will be the long-term support. So you can try with it. But 25 has given very new fascinating features, which were not there in the old version. I mean, still, you can say till 24 also. In 25, they have given features like no need to write a complete class. Directly, you can write main. More towards the Java scripting they are trying to take it. Get it? We will learn, don't worry. Everything I'm going to tell you. Your task is just to attend every day. Okay, keep learning, keep asking, okay, keep practicing, right? That is your work. So whichever you want, you can download. Like suppose I'm downloading the latest one, but I need the Windows one. So Linux, Mac OS is there. I'll take Windows, and this executable will be better. The installer, okay, the second one. So we will download that. So if you're using Windows machine, then download that. Now already in my machine, some other JDK is there. No problem. Later I'll uninstall that old one, and this one will get added. Okay. So that exe is downloaded. Just click on it. See, they're saying that the next one will come in September 2026, the next update. Okay. The moment I click on that exe, this dialog come. Just next, I said no rocket science. Okay. It will get installed in this program files Java folder, JDK. So the previous version may be there. Later I'll uninstall it. Don't, no worries. Next, and the installation will start. Generally, when you go for interview, uh, see to it that which is the latest one that you should know. Commonly, they'll check. They'll ask you which is the current version of Java going on, and that time you have a doubt. Getting so it's a good practice when you go for interview one day before. Just you ask to your AI tool the latest version, or you come to this website and check which one is the latest release. Okay, sometimes they'll not ask only that much. Okay, now if you say JDK 20 means they will know that you know the latest one. Then also go with their latest features. Just read the features. If you're not knowing in detail about it, at least features, and then tell one or two, and then you should say that yeah, I've only read it, but I've not explored it much. But these are the features in the latest one. Okay, it is successfully installed. I don't need the documentation and the tutorials and all. So I'll not go. I'll just close over here. Okay. Next step, what you have to do is you have to set the path so that you can use this JDK from any folder. Wherever you are, you will be able to use it. Okay. So it is a good practice to set that path in an environment variable. Okay. So environment variables means variables of your OS. They're variables of your operating system. Okay. And if you set the path, then you will be able to access the JDK and the tools and all from any folder wherever you are. Okay. So what I'll do is I'll go to program files. I guess it was installed here only. Is there a Java folder? Okay, so it was in this program files. Okay, in that, can you see Java folder? Now, can you see there are the older version also? Getting? So I'll go to this one which I just now installed, and the old I'll uninstall it. Don't worry. Okay, this is the latest one. Go inside, then go to bin, and inside bin you'll see all the tools are there, like Java profiler, your Java compiler, your virtual machine, the interpreter. Okay, then the debugger may be there, CJDB. So these are the tools present here. So I should be able to use this tool from anywhere, na guys. So copy this path. Say I'll just go up and copy this whole path. Okay. And then what you do is in the search, your search window, just search environment variable, env, okay, environment variable setting. Just you write env, just the moment you type few letters, it will come, and you open this. Okay, edit the system environment variable, that will come. I hope you got it. I just typed what? env. So you got this. Open. Okay. Then go to this environment variables. Okay. I hope. You're following what I'm telling you. And then
Yes.
you can see here in this, there is one path entry. These are all OS variables. Huh? I mean, these are the variables used by operating system for its purpose. Okay. C language and Python gives facility of reading all this in their program. Okay. So this is that path entry. Just double click on it. And at the end, you can add a new entry. Okay. So new and add this entry of this latest JDK. Okay. If there is an entry of the previous one, you can delete as well. See here, there is the entry of 25. So I can remove that entry or shift this up. Otherwise, what will happen? Still, it will keep using that 25. If I would have uninstalled, then automatically this entry would have gone. Getting? But I have not uninstalled it. Therefore, that entry is also there and the new one is also there. So better I'll just remove this. Okay. Right? I just did new and pasted that. Okay. 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 And okay. Done. Now the environment variables are set. Okay. If you want to test, you can just go to command prompt, CMD, and there you can just type Java minus minus version. So you'll come to know which version you are using. See, is it using the latest 26.0.1? Why? Because I deleted that 25 entry and I have added that 26 entry. So I added that 26 entry and that previous I deleted. And then I saved it, closed, and then I opened terminal. How to open this terminal? Not difficult, not to you people. Just type CMD, enter. Okay. And type and see which version. So Java minus minus version. So is it telling you that it is 26.0.1 published just now in April? Okay. So now it will, I guess they come with every 6 months or something. They have some cycle of coming with the next one. But the problem of Java is what it always adds the new thing in the older. So it becomes bulky. Okay. Whereas some technologies are there, they realize if it is bulky, they come with a complete new series. This is not in Java. Okay. So just test and tell me in your machine also you're able to see this. Or if you have not installed JDK, if you already have, then also you type and see this and tell me which version is currently in your machine. I need answer from your side. If you have typed this command in your machine and it is giving some answer, then unmute and tell me what is coming in your machine. Whether it is coming 17 or 25 or 24, whatever. Or if you have installed along with me now, so tell me that too. Okay, chalo, quick answer. I need answers from your side. Or you have not tried it, you want to do it later. Accordingly, you tell.
Sir, I tried it. I downloaded 25th version of Java, so I can see it.
Okay, so you got accordingly Java 25 point whatever. Others,
Yes.
others like you were having already, no problem. So if you were having already, then which version it is showing, that too you tell. Ideally, like if you are having Java 8 and above,
Sir, already having
so which version it is telling you if it's
Java
already
23.
23? No problem. Because anyway, in the initial stage, we are not going to learn the features of Java 25 and all. We are going to learn the basic things only, which are from Java 8. Okay. But Minimum Java 8 and above, you have to learn. Without that, don't go only for interviews. Means you don't know Java streams and Lambda uh, expressions. Okay, you don't know functional interfaces and all. Don't go only for interviews. Okay, ठीक है. So I hope this part is clear to you. Okay, so we will proceed with the next thing. Now we will start our programming journey. So some basics we will start learning. And when this all basic things are covered, like what are identifiers and then what are data types, literals, operators and all, then we will combine all this and make a complete program. Okay, so when we are at a stage of writing a complete program, then we will move ourselves to some IDE, either in VS Code or Eclipse. But Eclipse and VS Code, they are just tool to develop program. They all are going to ultimately use JDK in the background for compilation and execution and all. Okay, so don't think like if I have Eclipse means everything. No, if you want to install Eclipse, first you have to install JDK also. So we will switch to Eclipse later. Some basics we will cover first and then we will move ahead. Okay, right? So first basic thing we are going to learn, that is what are lexical tokens. So you can say lexical tokens means the smallest part of your program or the indivisible part of your code or the atomic part. Atomic means you understand atom. Atom cannot be divided this way. So atomic part of your code or the indivisible part of the code or the smallest piece of the source code is called as lexical tokens. Actually, that piece of text is called lexeme, and the category in which it belongs is called as token. Okay, so suppose I have written a program like class, then I wrote ABC, then brace bracket, then somewhere inside I've written some formula also, A equal to B into 3. So this class word is one atomic part. You cannot further divide it. You have to consider the smallest as this word only. So this is the piece of text of your program. So this is the lexeme, but it belongs to the category keyword. So keyword is a token, right? Keyword token. Operators are token. Punctuations are token. Getting? Same way, next, name of the class. So you have to consider that you cannot further divide it. This is a bracket, that is special symbol. Again, A is a variable identifier, equal to is the operator. So these are the smallest piece of your text, that is your program. They are the atomic part of your code. They are the indivisible part of your program. They are lexical tokens and they are the building blocks. Means using them only you're going to construct program. Okay, building blocks means you're understanding relate again. Like if you want to build a house, okay, so house is built using its building blocks, no? Like bricks are needed, cement is needed, water is needed, steel is needed, then labor is needed. So they all are what? Building blocks. And using that only houses are constructed, no? Right or no? Bungalows and apartments are constructed. So to construct that bungalows and apartment, what are the building blocks? I told bricks, cement, then water, then so many other things, then the labor. Okay, so same way to build your program, what are needed? Tokens are needed. Okay, okay. So what is the lexical token? I hope you got it. They are the smallest programming elements. Okay, and they are the building blocks for more complex construct. Like here I showed na, A equal to B into 3. So I have joined them and I made an expression. Getting? So those building blocks I used, one variable, then operator, then another variable, then again operator, then a literal, then a special symbol as a delimiter. And then I arrange them in a proper systematic way, grammatical uh, rule is followed. And then this is constructing what? A expression. So I have combined those building blocks using the grammar and I build some more complex things like expression. Many expressions are grouped into a block. I'll call it as a method. Then many methods I'll put in a class. Getting? So this way, gradually from small things, you are building complex things. Okay. So hope this thing is clear. So they are the smallest programming elements and they are building blocks for more complex constructs. Complex constructs means you got, na? Like I arranged that variables and operators and I formed an expression. Then similarly, many such statements I've written one below another, and then I'll form a block. So it becomes a method. Many methods I put in a class, so it will form a class. So class is made up of method, methods are made up of statement, statements are method made up of operators and variables. Getting?
Yes, sir.
Now what all tokens are there? Different types of tokens are there. First is the identifier. Identifiers are names which we give to our program elements, like name given to a class, name given to a method, name given to a variable, name given to a package. So name which we give, they are identifiers. Then literals, constant values. Just now I use in my program 3, a equal to b into 3. So did I use that 3 directly as a constant value? That is literal. Okay. Then we have lot of operators for doing operations like arithmetic operators. For comparison, we have logical operators, bitwise operators, so many. All we have to learn. There will be an exhaustive topic only on operators. Then there are some special symbols which acts like a punctuations and all. Like to indicate it is a start of a string, then we need double quote. Double quote indicates that this is a start of a string and the end of a string. Then how do you tell that it is the end of a statement? By putting a semicolon. Then how you tell that it is a start of a block? By putting brace bracket. So these are all special symbols which are having special meaning in your program. And then some reserve words are there, like how to tell that it is a start of a class. Then we use one reserve word, class. Class indicates that here the definition of class is starting. Okay. So reserve words are there. Like you want to tell that this is a variable of type integer. Then you write int I. So int is a reserve word. Reserve word means they have already some predefined meaning and they have to be used for that purpose only. We'll be learning all this Java keywords, Java identifier, Java literals. Okay. So all they are example of tokens. And remember, they are used for building complex constructs. Okay, they are used to build high level constructs. Like you can use this tokens to build expressions. From expressions, you can build statements. Okay, from statements, you can build methods. Many methods you can put and build classes. So this way, you're going from top-down approach. These small things are combined and form more complex. Then many complex things we use and create still more complex. And this way, ultimately, we reach to the class. Okay, in Java, the topmost thing is class. Na? Everything is put within a class. Okay, so this part is also clear to you, right? Then one more small concept we'll take to wind up with today's session. That is identifier. In this tokens only, we will complete with this identifiers part. So what are identifiers? Like you all people are having names. No? Your parents have given you meaningful name with a proper function, right or no? Your name, Shamali is there, then Gayatri is there, many are there, like, right or no? Prachi is there, then Garv is there, Nishant is there. So all of you are given some meaningful name by your parents with a proper naming ceremony and then it was announced to everyone that your name is so and so, and then the world is identifying you with that name. World is recognizing you with that name. Right or no? Clear? On that naming also nowadays on Insta, there are so many memes going on. Na? Amja Baratsa now so and so. Getting? So what I'm saying, as you people are having name, and with that name you are identified in the world, same way in your program, there are some elements to which programmer has to give name. And with that name, you recognize those elements. Like class name, when you're creating a class, so you have to give some name to the class. So that class name you have to give. That is the identifier. If you're putting your class in a package, then you have to give a name to the package. You're creating variables, then you have to give name to the variable because variables are user defined. We are creating it. So we only have to give meaningful name. So variables are there, labels are there. Getting? You create constants and literals. There is a confusion. Don't worry. I'll explain. But constants, labels, variables, methods. You're creating your own method. Today I created that get sal. So I gave a name to my method as get sal. Then I created a class and I gave name to the class as EMP. So EMP, that get sal, they are names given to identifiers, classes. They are identifiers. Okay. So what you'll remember, identifiers are name given to program elements like variables, packages, classes, labels, constants. Okay. So name given to program elements like package. Now you'll say, what is the package? Yesterday also we have discussed. It is just a folder. It's a computer directory. And inside that directory, group of what are kept? Classes. Related classes kept in it. Okay. The package. Same concept in Python also they have. Okay. Then name given to your classes and interfaces. We'll be learning what are interface. It's a very favorite topic in interview. Then methods. Okay. I added one get sal and then later I wrote e dot get sal round bracket. So name given to the method, then variables and constant, labels, all these are identifiers, and to all of them, I have to give the name. Okay, I have to give some name to them. With that name, they will be recognized. Get it? Okay. Now, whatever name you want to give, it has to follow naming rule, which Java people, those who created Java, those who have designed Java, they have set the rule. And the compiler will follow the rule. Means whenever you write program and then you give the program to compilation. So compiler will check that whether your class name, method name, variable name are following that rules or not. And if it is not following the rule, it is going to generate syntax errors at the time of compilation. Okay. So what those rules are? Identifier naming rules, right? So the rules are first, your identifier can be combination of letters, okay, digits, underscore. But now in from Java 21 and all, this underscore also they have kept as reserved. Okay, so standard rule you have to tell this only, but in 21 and above, no, they have kept 21 and above, no, sorry, in 9 only, in version 9 only, in version 9 only they have made this as a reserved word. It has they have kept it as a reserved literal. Okay, so we'll come to it, but rule wise, letters, digit, underscore, and currency symbols, currency signs. Okay, so many books only give dollar because what they say dollar is common or easy to type on the keyboard. The other currency symbols we cannot type no on the keyboard. Can I type euro sign or yen sign? But Java's Sun microsystems say you can use those currencies. But now you'll say how to type it. So you have to use their Unicodes. I'll tell you. They will have their Unicodes. You can use those Unicodes and use it. Okay. But common currency sign is dollar. And in letters also remember, not only A to Z, upper and lower. Uppercase A to Z, lowercase. Latin letters are also allowed. Now you say what Latin letters like alpha and beta and gamma, and then that A with a cap above it. They have some pronunciations are different. Latin is very much like Sanskrit, okay? Like sh and s and sh. Like Skoda car is there. So you can see that it is not Skoda, it is Skoda. The pronunciation is like that. On that Skoda spelling, no, there is one cap above it. Okay, so such Latin letters also you can use. But again, you'll say how I type this Latin letters. So if you're not able to type, you can use their Unicodes. How to use their Unicodes? I'll tell you, don't worry. So first point you have to remember, combination of letters, digit, underscore, and currency sign. Okay. If you read certification books of Java, Java is officially giving certifications also, but you have to pay their charges and you have to take the coupon 6 months, it is valid, then pay the charges for it, and then you have to Prometric centers are there. There you can online also nowadays is possible. You can give their exams. That certifications of Java are also very much powerful at the time of interviews. Many times, if you go to interview and you say, I'm Sun certified, then your interview is automatically made simple. They will not ask much question. Getting? So there are some certification books also, like Khalid Mughal, Kethi Siara, and all. In that, no, they have given rule that currency signs, euro, pound, yen, they also can be used. But many common books only mention dollar. Okay? So rule number one is clear. Second rule, at the first place, digit cannot come. Means in short, it cannot start with digit. Okay? So point two, you have to remember, cannot start with digit. Digit can come any other place. Means if I write 2ABC is wrong because it has started with 2. But if I write ABC2 is okay. Okay? So point 2 is also clear. Point 3, you cannot use reserve words. Means there are words which are having pre-decided meaning. Their purpose is decided. Keyword class, purpose is decided. To start the class definition. Int, float, if, for, while, break, continue. These words are having their original meaning and they're to be used for that purpose only. Therefore, you cannot use them for identifiers. Means I cannot create a variable like this. Int, and here I'm writing for equal to 40. Correct? Means I cannot create a variable with the name for and assigning 40, a variable of type integer, but the name is for. Wrong, because for is a reserved word. Its purpose is already decided. You cannot use it for this purpose. Correct? As a variable name, you cannot use it. Same rule is in our natural languages also. No? Like in English, Hindi, Marathi also, there are some reserved words. Like in English, we have some reserved words like articles are there, right or no? Verbs are there. Verbs like run, go, sleep, eat. So can I give name as eat to a boy? Right? My son's name is Run. So funny, no? You will for hearing also it is funny and grammatically also wrong. Get it? So you cannot use. But nouns which are human created, nouns are human created. That you can give it to anyone. Like June. June is the name of month also and girl also. My sister's name is June, and next month is June. No problem. Because it is a noun, human created, it is not a reserved word. Correct? So in our identifiers also, we cannot use reserved words. Agreed? Point number three. Then they are case sensitive, meaning if I create a variable age and I create a variable age with a capital, Java will treat both of them different. Getting? Now, I can show it in that J shell also. In J shell, I would have proved it. Both are different variable because case is different. Okay, so it is case sensitive. Okay, and last point you have to remember, no limit on length. There is no limit on length. You can create any big identifier. But again, you are wise people, right or no? You will not create such huge variable. No? You will not create a variable like this. My life first salary, okay, of month Jan 2026. Foolish person will create a variable like this. If you create, it won't give error, but so much difficulty to use this variable below in the code. In the code, if you need this variable 10 places, is it easy? No. But if you are creating a variable with the name sal or maximum salary, it's sufficient. You come to know that what the purpose is. Correct? So there is no limit on length, but obviously, as there is no limit, you will not, like a donkey, will not create a variable of any size. Wisely, you will use the length. Okay. So 5 rules are clear to you. Quickly, we'll go through the rule. Okay. First rule you have to remember any sequence of characters. Which characters? Letters. In letters, remember uppercase A to Z, lowercase A to Z. Some Latin letters are also allowed. Digit 0 to 9, underscore, and currency symbol. Okay. Rule number two, first character in an identifier cannot be a digit. Means it cannot start with a digit. Then all identifiers are case sensitive and cannot use reserve words, that is keyword, and no limit on length. Okay? I hope it is clear. Quick confirmation you can give me. All these are elementary programming concepts. Huh? So once we complete with all these elementary things, then only we'll start developing big programs. Huh? Okay? Okay, so for today, we will take pause over here only, guys. In the next session, we'll see some valid, invalid identifiers. Then we will talk about keywords, then literals, okay, operators, data type. Before that, data types, all one by one we will learn. And simultaneously, I'll show you that small code is in that J shell. Okay. And once we are at a stage of writing a complete program, then we will switch to either VS Code or Eclipse, and then we'll start writing a complete program. Okay. Okay. So for today, we
Okay,
will
sir.
stop over here. Thank you, all of you.